This video introduces the concept of probability and how to calculate the probability of an outcome. We are asked to calculate what is the probability of flipping two heads in two tosses of a coin. Step 1. Understand the question. What do we mean by the probability of two heads? Let's say that we have a certain number of possible outcomes or results. For example, rolling a die has 6 possible outcomes, 1 through to 6. And let's say they are all equally likely. Again, when rolling a die, each possible result is just as likely as any other. Usually, we only want or are interested in some of the possible outcomes, like if we wanted to roll a 6, or in our example question, we wanted 2 heads. Then the probability of the outcome we want is equal to the number of desirable outcomes divided by the total number of possible outcomes. So we need to determine how many ways there are of flipping 2 heads and how many possible outcomes there are in total. In probability, it is often helpful to visualise the situation. Here we will use a visualisation technique known as a probability tree to do this. That's the plan. A probability tree starts out at a single point, and for each event, it branches out into a number of equally likely possible outcomes. In this case, we can consider the coins being flipped separately, because flipping one coin has no effect on the other coin. When we flip a single coin, there are 2 equally likely options, heads and tails. Therefore, our tree goes into 2 branches, heads and tails. Now we flip the second coin. It also has 2 equally likely outcomes, so each of our 2 branches now branch into 2 more, so we have 4 total branches. Now we can see that there are a total of 4 possible outcomes, and only one of the branches has 2 heads. So our probability is equal to the number of desirable outcomes, which is 1, over the total number of outcomes, which is 4. So our answer is 1/4 or 25%. It can be difficult to know if a probability answer is correct or not, but we can catch obvious mistakes. If the answer is bigger than 1 or 100%, or if the sum of different probabilities is bigger than 1 or 100%, then something must be wrong. For example, the probability of 2 heads plus getting the probability of 2 tails must be less than 100%. Since we know that the chance of getting 2 tails has to be the same as 2 heads, then the probability of 2 heads must be less than 50%. Similarly, if the answer is negative, we know that that is wrong. Taking all those things into consideration, 25% seems like a reasonable answer. What if we flip the first 2 coins, as well as a third coin that is twice as likely to land on heads as tails? What is the probability of exactly 2 heads? Well, we can use our tree from before and extend it for the third coin. As we said before, each branch of the tree must be an equally likely outcome. We can accommodate this by giving each branch from before 3 new branches, 2 heads, 1 tail. Now each of these outcomes are equally likely, 2 heads outcome and 1 tails outcome. By counting up the total number of branches, we can see that there are now 12 equally likely outcomes, of which 5 have 2 heads. So our probability is now 5/12, or roughly 41.7%.